Hello class, welcome to Algebra Lesson 1-7, Solving Absolute Value Inequalities. By the end of this lesson, you should be able to write and solve absolute value inequalities. Let's jump right in with our first example. We have understand absolute value inequalities. What are the solutions of an absolute value inequality? So absolute value inequalities are going to work pretty similarly to what you learned about with absolute value equations, where you're going to kind of have two different answers. You're going to have that case 1 and that case 2 scenario, but it's also going to combine the knowledge that you have of inequalities, okay? So let's look at these two different absolute value inequalities. So the first one, if we look at, we have the absolute value of x is less than 3. So case 1 is that x is less than 3. It's as simple as that. Case 2 works the same way, where you have x, you change this to a -3, but with inequalities for case 2, when you make that other value negative, you have to also flip your sign. Okay, so for case 2 with the inequalities, you flip the sign, and whatever it's being compared with, in this case the 3, you make it negative. So then let's say this is -3, -2, -1, 0, 1, 2, 3. Let's graph this. Case 1, x is less than 3, and it's an open circle because it's not less than or equal to. Then we have case 2, x is greater than -3, so I know that it is going to be filled in between those two lines. When it's filled in and has two endpoints like that, our answer is an and. So I'm going to say x is less than 3 and x is greater than -3. Okay, let's look at the other one over on the right. We have absolute value of x is greater than 3. So our case 1, we leave it just like it is. I say x is greater than 3. Case 2, I am going to say x, flip my sign, so I'm flip it to less than, and I make that a -3. So again, I'm going to say -3, -2, -1, 0, 1, 2, 3. So x is greater than 3. So again, open circle, but greater than 3 means I'm going to point to the right. Then we have x is less than -3. So that's going to point to the left. And when the two arrows point in opposite directions, this is an or inequality. Or compound inequality, sorry. Words are tough. So that's all you have to do. Why don't you try graphing or solving and graphing this inequality on your own? Good luck. All right, for this one, hopefully you said x is less than or equal to 7 and x is greater than or equal to -7. Your graph looked something like what I have. And remember, with an and compound inequality, you can always write it just like this, where you put the smallest number on the left, biggest number on the right, x in the middle, and then put the signs there. All right, example 2, solve absolute value inequalities. So first, before I even solve this problem, I want to talk about one situation, because we always talk about how to get a no solution, right? So here, you see how everything is in the absolute value? Absolutely everything is in the absolute value. So that means doesn't matter what we plug in for n, this number is going to be a positive, right? It's going to be a positive number because it is everything is included in absolute value. So if we ever have a positive number, and then you see how we have less than or equal to, if this were a -5, so say this ends up being a negative number, can a positive ever be less than or equal to a negative? No. So if you ever have an instance where a positive is less than or equal to a negative, that is called a no solution. Okay? So if you ever have a positive is less than or equal to a negative, that is a no solution. But I'm going to jump back and I am going to solve this one. So I have absolute values all by itself, so I can jump right into case 1 and case 2. So I have 2n plus 3 is less than or equal to 5. And then I have case 2, which is 2n plus 3. I flip my sign and I make that a negative. Okay? And Notice that this is now different than that no solution I showed you, because once you split it into case 1, case 2, that absolute value goes away. So it doesn't matter if we have a negative number, plus the sign flipped, right? So positive is greater than a negative. That's always true. Okay, so jumping back to case 1, case 2, let's solve this. I'm going to start by subtracting 3 from both sides. So I have 2n is less than or equal to 2, because 5 minus 3 is 2. And then divide both sides by 2, n is less than or equal to 1. Then over in case 2, I'm going to subtract 3 from both sides. I have negative 5 minus 3 is negative 8. Let me just fix that. And then divide both sides by 2. N is greater than or equal to negative 4. So I have a negative 4, negative 3, negative 2, negative 1, 0, 1. I have a filled in circle at 1, and it's less than that number, but it's also greater than negative 4. So I'm going to go all the way over to 4, put a filled in circle there. I know that this is an and statement, so I can write n is less than or equal to 1 and n is greater than or equal to negative 4, or I can write it like this. Okay, both options are good to go. Let's look at the second one. I have 3 outside my absolute value, so what I need to do is get absolute value separated all by itself before I split into case 1, case 2. So I'm going to divide both sides by that 3. So I'm going to say the absolute value of 2x is greater than or equal to 4. Now that I only have absolute value on the left side, I'm going to divide both sides by 2, or split into case 1, case 2, sorry, case 1. I'm going to divide both sides by 2, and I get x is greater than or equal to 2. And then case 2, I say 2x, I flip my sign and make it a negative 4. Divide both sides by 2, x is less than or equal to negative 2. So let's say this is negative 2, negative 1, 0, 1, 2. I have a filled in circle at both 2 and negative 2. And then x is greater than or equal to 2. So I go out that way, and x is less than or equal to negative 2, so I go out that way. So this is actually an or statement, okay? So x is greater than or equal to 2, or x is less than or equal to negative 2. And that is my answer. All right, I want you to try to solve this problem on your own. I'll give you a hint, though. Remember, you need to get the absolute value all by itself before you can split into case 1, case 2. Good luck. Okay, hopefully for this one you ended up with x is greater than negative 6 and x is less than 2, and your graph looked something like mine. If you have questions about that, please don't hesitate to ask. One of the common errors I would say probably happens with this problem is either forgetting to isolate the absolute value before you did case 1, case 2, or when you moved that negative 2 to the other side, you did negative 16 divided by negative 2, that becomes a positive 8. But since you divided both sides by that negative 2, you had to flip your sign before you did case 1 or case 2. So those are a couple of common errors that I could see happening with this problem. All right, let's look at example 3. We have members of the debate team are traveling to a tournament where they stay in a hotel for 4 nights. The total cost for each member must be within $20 of $175. Which of the hotels shown can they consider? All right, so for this problem, let's practice writing that absolute value inequality. We know we're going to stay 4 nights, and then I'm not sure what the cost is yet because I don't know which hotel I'm looking at first. So I'm going to do 4x minus 175, because that's kind of the total that we're aiming for. I'm going to do absolute value around that because I want to know the distance between the actual cost and 175, because I need that to be less than or equal to $20, so that way it's within our budget. Okay, so this is the cost of the hotel minus how much we're allowed to spend, and I need that to be within that $20, so I need it to be less than or equal to $20. So if we try this out with a couple of different, so hotel A, for example, the absolute value of 4 times 40 minus 175, is that less than or equal to 20? So 4 times 40 is 160. 160 minus 175 is negative 15. The absolute value of negative 15 is just 15. So is 15 less than or equal to 20? Yes. So hotel A is one answer. And then hotel B, I'll switch colors just to make it a little easier. So green. So we have B. I'm going to do absolute value of 4 nights times $45 minus 175. So 4 times 45 is 180. 180 minus 175 is 5. So the absolute value of 5 equals 5. Is 5 less than or equal to 20? Yes. So we know hotel B is an option. And then let's check hotel C. So hotel C, again, we're going to do 4 times, and then this time 50 minus 175. 4 times 50 is 200. 200 minus 175 is 25. The absolute value of 25 is 25. Is 25 less than or equal to 20? No. So hotel C is not a hotel they can consider. So the 2 options they have are hotel A or hotel B. Now I want you to take that same train of thought and think about if the debate team increased their limit to $200 plus or minus $20, would they be able to afford hotel D, which did not exist on the last slide, at $55 per night? Explain. Good luck. All right, hopefully for this last one, you set it up kind of the same way. You said 4 times the amount, because 4 is the number of nights. 4 times 55 in this case. And then you would subtract 200 because that's the amount of money they're allowed to spend. And then you do the absolute value of that number. In that case, in our case, it was 20. The absolute value of 20 is 20. So then we say, is 20 less than or equal to 20? Yes. So your answer would be yes, the total cost is $220, which is within that $20 range. The explanation, honestly, this is an explanation to me. Okay, if you can show me that work, that counts as an explanation. All right, and then this last slide just kind of walks you through how to tell if it's an and or an or, and how to kind of solve those. Okay, if you have any questions at all, please don't hesitate to reach out for some help. I am more than happy to help you. Have a great day.